Hello everyone, Polynomial Functions of Higher Degree, Section 3.2. Here I have examples of continuous and discontinuous functions and the definition of what a continuous function is. So continuous, continuous, discontinuous, there's a jump. This is continuous, but it has a sharp turn. Polynomial functions don't have sharp turns. This is discontinuous, discontinuous because there's a hole, continuous, discontinuous because there's a hole. This one has a hole, but it's filled in above the hole. Even though it is all real numbers for the domain, this still is this point of discontinuity. This is also all real numbers in the domain, but it has a point of discontinuity here at 0. I have examples of what your parent graphs look like. You learned these parent graphs back in Algebra 2. X cubed, x to the 4th, x to the 5th, 6th, 7th, and 8th. And what you want to notice is the pattern. Odds, down to the left, up to the right. Evens, up to the left, up to the right. Or as x goes to negative infinity, for the even functions, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. For odd functions, as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. And that's spelled out here. And we can get into example 1. Describe how the graphs of the following polynomial functions are related to their parent graph. So here we have a negative out in front, so reflected in the x-axis, and as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to negative infinity. So it's the opposite of the x to the 5th graph, which is here. Instead of going down to the left, up to the right, it's going to go up to the left, down to the right, because it's been flipped over the x-axis. B, we have a vertical shift, up 1. Up 1. And as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. Up left, up right. Part C, here we have a horizontal shift. And horizontal shifts are counterintuitive, and this looks like it might go to the right, but it doesn't. It goes left 1 unit. Should put a unit here. And the end behavior, up left, up right. So, I've just got to circle this instead of rewriting. Part D, we have a flip and it's cubic. So reflected in the x-axis, and as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. Part E, positive and even. So no reflection, and it's going to be as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. And part F, odd function, no reflection, no shifting, as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. What are zeros? Zeros are where the x-axis, where the graph crosses the x-axis, or the x-intercepts. Find the zeros for example 2, and then we're going to sketch using the zeros and the end behavior. So first of all, let's take a look at the end behavior. Down left, up right. I just like to make little notes so that I remember where to put the end behavior. And now let's find where the zeros are. So x cubed minus x squared minus 2x equals 0. Factor out the x. X squared minus x minus 2 equals 0. X minus 2, x plus 1. So x equals 0, negative 1, 2. So let's see. That's 2.5. That's 2. I think this is 1 here. So here's the negative 1. Here's 0. And here's 2. Okay. I know it's got a end going down. It's got to go up. It's got to come back down to hit the 0 here. Come back, hit the 0 here. And then I got to remember it's got to end going up. So that's a pretty good representation of the graph here. I don't know where these turning points are yet. That's lessons for the future. Part B. Let's take a look at the end behavior. It's reflected in the x-axis and it's even. So it's going to be down, down. Let's find the zeros. 2x to the 4th plus 2x squared equals 0. 2x squared, x squared plus 2 equals 0. X equals 0, double root. And x equals plus or minus I square root 2. Oh, nope. I copied wrong. There's a negative there. So if I factor out this negative, this becomes minus. So it's not I. It's just plus or minus square root of 2. So that means 1.4, so 1.5, right around here, negative 1.5, positive 1.5, 1.4 is square root 2. Okay, so negative square root 2, positive square root 2, and 0 is a double root. Double roots are bounces. What do I mean by that? It means that the function comes and it bounces off of that 0. It doesn't cross through the 0, it bounces up off that 0. So where does it bounce from? Well, let's take a look at our ends. So it's got to come up and up, which means it's got to come down, bounce, and go back down again. Part C, So this is a little more advanced than what you've done so far. Let's take a look. We know what the end behavior is going to be. Okay, it's positive and odd. So down left, up right. Okay, what we need is some way of knowing what the zeros are going to be. Well, let's take a look at a chart of graphs. What do I mean by that? I meant just a chart. X, h of x chart. So let's try values like -2, -1, 0, 1, 2. So we're going in increments of one unit increments here. Okay, so when I put -2 in, let's go off to the side here. So we'll do h of -2 equals -2 to the 5th minus 3 times -2 cubed minus -2 squared minus 4 times -2 minus 1. 2 to the 5th is 32. It's negative, so we have -32. 2 cubed is -2 cubed is -8 times a -3 is a positive 24 minus 4 plus 8 minus 1. -32 plus 24, that's going to be -8, 0, -5. So we have -2, -5. All right, -2, -5. Okay, h of -1. So we have -1 to the 5th minus 3 times -1 cubed minus -1 squared minus 4 times -1 minus 1. -1 to the 5th is -1. -1 cubed is -1 times -3 is positive 3. -1 squared is 1 times negative is -1. Positive 4 minus 1. -1 plus 3 is 2. Minus 1 is 1. Plus 4 is 5. Minus 1 is 4. So I have -1, comma 4. All right. What's important about that? Why did I show you these two? There's something important happening here and here, in between these. This is a polynomial function, and this is why we talked about in the beginning of the unit and in the last unit continuous functions. And it's so important for a function to be smooth and continuous for us. This is a polynomial function, so it has to be smooth and continuous. If it's continuous, then I can't get from -5 to +4 without crossing the x-axis, without lifting my pencil up. Well, I don't lift my pencil up because it's continuous, so the only way for me to go from -5 to +4 is I have to cross the x-axis. Now, it's possible I cross the x-axis multiple times before I go back up to the +4. I don't know for certain, but I know that there is at least one 0. We have found a 0 of the function. There's at least one 0 there. There may be more than one, but there's at least one 0 there. Okay? Now, let's put in 0, h of 0. H of 0, I'm not even going to write it all out, is -1. 0 is negative 1. It has to cross the x-axis. Again, we found another 0. Has to. Okay? Try h of 1. So 1 to the 5th minus 3 times 1 cubed minus 1 squared minus 4 times 1 minus 1. 1 minus 3. 1 minus 3 minus 1 minus 4 minus 1. 1 minus 3 is negative 2, negative 3, negative 7, negative 8. So, I'm not sure, do I have a negative? I don't have a negative 8 on here. It's somewhere down here. 5, 5.5, somewhere down here. Okay. What's important, there isn't a 0. I know there's not another 0 there. Okay. Let's try h of 2. See what we get. 2 to the 5th minus 3 times 2 cubed minus 2 squared minus 4 times 2 minus 1. 2 to the 5th is 32 minus 2 cubed is 8 times negative 3 is minus 24. Minus 4 minus 8 minus 1. 32 minus 24 is going to be 8. 8 minus 8 is 0. I'm at negative 5. So I didn't find another 0. But I can still plot that point. And it looks to me like it's starting to come back up again, and that we might be able to find another 0, maybe if we try 3. Okay, so I'm going to pause the video while, instead of you watching me do the calculation, I'm going to pull up my calculator. So I did kind of quickly, and I might have made a mistake, but I just got 140. The point is, I've got another 0. I have found another 0 at 3, and then something way, way up here. Okay. Now, I'm not going to hone in. Technically, there are 5 zeros. I'm not going to hone in to try and find the other 2. It's possible that they are imaginary. We might never be able to find them. They may be in between these or these. We don't know. But I know that the basic shape here is going to do something like this. It's not perfect, but we get a ballpark idea of what our graph needs to look like. Now, this procedure that I'm doing here leads us into the intermediate value theorem, which basically says that let a between any 2 points A and B, the function f of A and f of B has to take on every value between f of A and f of B. So between -2 and -1, the function has to take on all the values between -5 and 4. So the function, because it's continuous, has to have a -3 in there. It has to have a 2 in there. It's got to have a 1 in there. Everything between -5 and 4. Now, it could have stuff outside of that range, but it can't skip anything. It can't skip a -1. It can't skip a positive 1. And most importantly, it can't skip a 0. It has to have a 0. That's the intermediate value theorem. Example 3. And we're going to use the intermediate value theorem in future problems. So find the functions, the polynomial functions with the following zeros. There may be many solutions, right? So we know that we've got a -2, a -1, a 1, and a 2. So we have f of x equals a x plus 2, x plus 1, x minus 1, and x minus 2. So here's our function. I'm not going to try and find the a right now. In fact, I'm just going to, just for this purpose, let a equal 1. There will be other problems in the future where we'll be able to find the a value. I'll tell you what the f of 3 equals 4 or something random like that, and we'll be able to calculate the a value. But for now, I'm just going to say a equals 1, or you can leave it as a. X plus 2 times x minus 2 and x plus 1 times x minus 1 are easier to do together. So we have x squared minus 4, x squared minus 1. A. Now we'll double distribute. X to the 4th minus x squared minus 4x squared plus 4. A. X to the 4th minus 5x squared plus 4, so on and so forth. So that's a good place to stop. I will even accept if you stop here. Okay, this is better, but this is acceptable. Okay, part B, we have -1/2 and then 3 double root. So we have, let's go g of x this time. And again, I'm just going to make a equal 1. So I should have just erased the a's here and didn't need the parentheses anymore. And again, I'm just going to make a equal 1 on this one, so I'm not even going to put the a in there. So -1/2 is 2x plus 1, and then 3 double root is x minus 3 squared, or x minus 3, x minus 3, double root, 2x plus 1, x squared minus 6x plus 9, double distribute, so we have 2x cubed minus 12x squared plus 18x plus x squared minus 6x plus 9, 2x cubed, looks like minus 11x squared plus 12x plus 9. And that would be a good g of x function. All right, sketch the graph of f of x equals 3x to the 4th minus 4x cubed. Let's take a look at the end behavior first. It's positive and even. So up left, up right. Let's take a look at zeros. 3x to the 4th minus 4x cubed equals 0. X cubed, and we've got 3x minus 4 equals 0. So x equals 0 triple root, different from a double root. Triple roots do cross through, they don't bounce. And 1 1/3. Positive 1 1/3. So we have 1 1/3. If that's 1 1/2, say 1 1/3 right about here. And 0 is a triple root. know it's got to start up. Going to come down. Then it's going to cross through and go up. And we don't know where this turning point is. I think it's actually way down low, but that doesn't matter. That's for a future lesson. And example 5. Using the intermediate value theorem, we want to find 3 intervals of length 1, which the polynomial f of x is guaranteed to have a 0. So I don't need you to graph it. We're just doing x f of x in 1 unit intervals. Start around 0, so start maybe -2, -1, 0, 1, 2. If we need to go out further to find a third interval, we will. So f of -2, 12 times -8 minus 32 times 4 minus 6 plus 5. Now, all I really care about is it positive or is it negative? That's negative, 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 and the plus 5. This is negative. Why do I only care if it's negative? Because if this is negative, then there's no 0. But if this is positive, then I found a 0. Okay, so f of -1, 12 times -1, minus 32 times +1, minus 3 plus 5, -12, -32, minus 3, it's negative again. No 0. Okay, 0 is 5. Just found a 0. Let's find f of 1, +1. Well, f of 0 was 5. F of +1, so 12 times 1 minus 32 times 1 plus 3 plus 5. So we have 12 minus 32. That's negative 20 plus 8. It's negative. Another 0. We only have to find one more. Now, maybe here, I might have to go back to -3. Might have to go forward to +3. Let's hope. If we put in f of 2. We'll see. So 12 times 8 minus 32 times 4 plus 6 plus 5. So 80, 96. Oh, let's see here. Pull out my calculator. 12 times 8 is 96. Minus 32 times 4. Negative 32 plus 6 plus 5 is a negative number. Didn't find another 0. Okay. I'm going to try -3. I don't know why. Maybe it's +3, but I'm going to try -3. I just haven't... No, change my mind. I'm going to try +3. My instincts are now telling me +3. If I try -3, f of -3, we're going to get 12 times -27 minus 32 times 9 minus 9 plus 5. negative, 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 plus 5. This is negative, so negative 3. Negative. Positive 3, I have a feeling we want to check from 2 to positive, from positive 2 to positive 3. So I have a feeling that f of 3 is going to end up as a positive number. It's 12 times positive 27 minus 32 times 9 plus 9 plus 5. And let's see. Oh yeah, that's definitely positive. 12 times 27 is huge. Minus 32 times 9 plus 9 plus 5. 50 positive. And there is my, oh no, sorry. From 2 to 3 is my other 0. Okay, so I went in 1 unit intervals, length of 1 unit intervals. I found a 0 between negative 1 and 0, between 0 and 1, and between positive 2 and positive 3. There are only 3 zeros in this function because it's cubic. So we found the intervals in which those 3 zeros occur. We could get a pretty good picture going forward. Here's your IXL and your bookwork to work on. Thank you very much. Bye.